In a frequency table, they have gone through and taken all of the list of raw data and figured out how many of the data elements are the same, and then grouped them together. So this frequency table means that there was one car that got 19 miles per gallon. There were 4 cars that got 20 miles per gallon, 2 that got 21, and so on. So the raw data, if it were in order even, which it wouldn't be when you first got it, would have been, there would be 119, there would be 4 20s, there would be 2 21s, etc. Now, to get the mean, if we were to add all of these up, we would have 1 times 19 plus 4 20s plus 2 21s, etc. So to get your mean, you want to take the category number times the frequency, plus the next category times the frequency, plus the next category times the frequency, and so on. That's how you're going to get the sum of all the data. And then since we want the average, the mean, and you have to divide by the number of data elements, you divide by the sum of the frequencies. So we get the sum of the frequencies times the data element divided by the sum of the frequencies. And this is going to be the same thing as n. The sum of the frequencies tells you how many data elements there were. Now in this case, we've got a little bit of a cheat because it says there's 56. So these numbers should all add up to 56. So that's how you get the mean. You take the category, which is numerical and it represents what the data actually was, times its frequency all the way across, and then divide by the number of elements, which would be the same as the sum of the frequencies. To get the median is, of course, the middle number. Now, if you've got 3 data elements, let's say 5, 8, and 12, the middle number here is going to be 8. So we notice in this case, n is 3. There are 3 data elements. Half of n, to get the middle, would be 1.5. So if you have an odd number of data elements, 3 is an odd number, take half of that and bump it up to the next integer. The next integer will give you the position of the middle number. We know if there are 3 numbers, the middle position is in slot 2. If you have an even number of data elements, so here n is 4. If you've got an even number of data elements, you get the 2 middle ones and you average them, you get their mean. So you add them together, divide by 2. So to get the middle position figured out, you take half of that. In this case, half of n would be 2. And then you want to get the mean of the one in number 2 and the data element in position 3. This is first, second, third, fourth. So the second one is not actually in the middle. In the middle would be halfway between the middle 2, where you have an even number of data elements. Now, in this case, we actually have 56 data elements. We already know that, but you could get that if we weren't given that by adding these up. This is even. So half of 56 would be 28. We want to get the mean of the 28th and 29th. Now, to get the 28th, we want to add up the frequencies because the first one was 19, the next 4 were 20, the next 2 were 21, so we're up to position 5, 6, 7, 17. 17 plus 7 would be 24, 25, 26, 27, 28 would be into both the 28th and the 29th numbers are both going to be 25s. So when you put the cars in order from the smallest miles per gallon to the largest, the cars sitting in the 28th and 29th positions both got 25 miles per hour. So if we enter 25 here, perfect. Now, as far as the mode is really simple, especially if you've got a frequency table. The mode is the number that appears the most often. We have 8 25s and 8 26s because this is a tie. The mode will be tied at 25 and 26. So that's how you get the mean, median, and mode from a frequency table.